Welcome, everyone, to our deep dive.
Mm-hmm.
Today, we're looking at something probably sitting in your fridge right now, yogurt.
Mm-hmm. Creamy, tangy. It's everywhere.
Exactly.
Yeah.
But, have you ever really stopped to think about what it is? Like, how does milk turn into, well, yogurt?
It's a pretty amazing process,
So
actually.
that's our mission today. We've looked at some biochemical studies, a bit of culinary history,
Cool.
and we want to unpack this.
Great.
Okay, so at its heart, yogurt is fermented milk. Simple, right? But it's really milk transformed by beneficial microbes, little helpers.
Tiny chefs,
Yeah.
almost.
Yeah, and we'll get into how the milk itself, the fat globules, the lactose sugar, those famous casein proteins, how all that changes.
And it's worth stressing why that change matters. It's not just about taste.
Good point. Let's talk benefits first.
Well, the big one is digestion, that fermentation. It breaks down lactose. So people with lactose intolerance often find yogurt much easier to handle than milk.
That's huge for a lot of people.
Definitely. And then there are the probiotics. These are the live, friendly bacteria themselves, and they're fantastic for your gut health, your microbiome.
And there's even research linking gut health to other things, right? Like mood.
Exactly. The gut-brain axis. It's a really active area of research suggesting these bacteria could play a role in, well, all sorts of things. Plus, you still get the protein, the calcium, the vitamins. It's nutritionally dense.
Okay, so the health side is clear.
Yeah.
But the transformation itself, that's where I find it really fascinating. How do we get from liquid milk to this, thick, spoonable stuff? What's the core process?
It all comes down to lactic acid fermentation. It's a process we see elsewhere, too. Think sauerkraut, kimchi, even sourdough bread.
Okay. Same family of processes.
Right, but for yogurt, there's a specific A team of bacteria involved. We're talking Lactobacillus bulgaricus and Streptococcus thermophilus.
Those are cystic too.
Yes, they work together beautifully. They're thermophilic, meaning they love warmth, which is why you typically heat the milk first before adding the culture.
Right. Create a nice warm environment for them.
Precisely. And they have this cooperative relationship. Streptococcus often gets things going, lowering the pH a bit, which then helps lactobacillus really kick into high gear and produce even more acid. It's quite elegant.
So we add these cultures to the warm milk. What are they actually doing in there? What's their food?
They immediately start feasting on the lactose. That's the natural sugar in the milk. It's their energy source.
Okay, so they're eating the milk sugar,
Mm-hmm.
and as they metabolize that, they're producing something important, I gather, for the texture and taste.
That's the crucial part. As a byproduct of eating that lactose, they produce lactic acid, and this is where the magic happens.
Okay. Lactic acid, what does it do?
Well, as the lactic acid builds up, the pH of the milk drops significantly. It goes from nearly neutral, maybe 6.7, down to quite acidic, like 4.5 or even a bit lower.
Wow, that's quite a change.
It is. And this increased acidity is the key. It causes the main proteins in milk, the casein proteins, which are normally bundled up in these little spheres called micelles. Okay.
It causes them to unfold or denature and then tangle up with each other. They form this intricate three-dimensional mesh or network,
Like a net.
exactly like a net. And that network traps the water and fat, creating the gel structure. That's what gives yogurt its thickness, its characteristic texture.
So without that specific acid level, the proteins wouldn't tangle up like that.
Nope, you just end up with sour milk, not yogurt.
Yeah.
That controlled acidification is everything for the texture. It's really quite clever food science happening naturally.
That makes perfect sense. And I assume that same lactic acid is responsible for the taste, too. That tanginess.
You got it. The lactic acid provides that distinctive tangy flavor. And
Yeah.
generally, the longer you let it ferment, the more acid gets produced and the tannier the final yogurt will be.
So that explains why some yogurts are milder and others are really sharp.
Precisely. And it also relates to texture differences like you see in, say, Greek yogurt or skyr, where they strain off some of the liquid whey.
Right, concentrating that protein network even more. So if you step back, it's fundamentally a two-step thing. You give the bacteria the right conditions in the milk.
The warmth, the lactose.
Yeah. And they, in turn, change the environment, make it acidic, which transforms the milk's structure and gives us that final taste and texture. Simple concept, but biochemically fascinating.
It really is. So next time you're, spooning out some yogurt, take a second. Appreciate the microscopic heavy lifting that went into it.
Those little scientists did all the work.
They really did. It's amazing how we've harnessed this natural process.
And it makes you wonder, doesn't it? What other everyday foods in your kitchen are hiding these incredible sort of secret scientific transformations powered by microbes we don't even think about?
That's a great thought to leave folks with. Maybe your sourdough starter, your cheese.
Maybe even that pickle jar. Definitely something to mull over until our next deep dive.